Hello students, welcome to section 12.2, surface areas of prisms and cylinders. Prisms are polyhedrons with congruent polygonal bases in parallel planes, which is what we actually saw in section 12.1. Cylinders have congruent and parallel circular bases. An altitude is a perpendicular segment joining the planes of the bases. The length of an altitude is the height of the figure. Right prisms have lateral edges that are altitudes, and a right cylinder is one whose axis is an altitude. Okay, so there's a lot of information there, some of which you already know, some of which you don't, but the picture is very nice. So if we look at the picture here, what we see here is on the left, we've got a polyhedron. It happens to be a pentagonal prism because the bases are both pentagons. They are parallel to one another. This base, which is a pentagon, is parallel to that base, and they are also congruent polygons. They're parallel to each other. Let's see, we've got a lateral edge right here. A lateral edge is where you have essentially faces intersect each other, particularly though the base and one of the lateral faces. So the faces that surround the prism that are not bases are called faces, okay? Lateral faces more specifically. They're all faces technically, but the sides of the polygon, or excuse me, the prism, not including the congruent polygons, those are lateral faces. Okay. At the bottom, you see capital B as the base area. I'll be using capital B in different instances today. And then you've got the capital P using that in context as the base perimeter. So area versus perimeter of the base. And then last but not least, the H, as they describe here in the paragraph above, is the height of the altitudes, or the length of an altitude as the height. Right prisms have lateral edges that are altitudes, and a right cylinder, I'll go back, is one whose axis is an altitude. Before I talk about the cylinder, notice here that this particular altitude, or H value, is in fact a 90-degree relationship being formed with the base. So there is a little right angle here that you need to take into account. So these, um, let's say just segments, we'll call them for now, although they are edges as well. These segments are technically going to form 90 degrees with the base. All right, now to the cylinder. The cylinder does in fact have, as it suggests again, a right cylinder, in fact, a 90-degree angle as well. So the height of the cylinder H is perpendicular to the bases. Certainly you can see the right angle there with this base, but it's also perpendicular, forming a right angle to the top base. Speaking of the bases, the top base is a circle, as is the bottom base. Now, there is no capital B here, but in a little bit I'll use capital B for the area of this base. And if you recall from circles, the area of a circle is pi r squared. So I'll be using capital B equals pi r squared. We'll also discuss perimeter in a sense, although circles we don't typically use perimeter. But if you think about the circumference of the circle, 2 pi r in context, that'll be something we apply later. R being the radius, and again, h being the height. In the following formulas, capital L is lateral and capital S is surface area. Okay, so prisms, capital L. There's your prism, let's just say, to highlight the formula with, or any prism, I guess. But if you look at this prism, capital P, the perimeter of the base, times the height. It's as easy as that. Once you know the perimeter and the height, the perimeter of the base, that is, and the height, you are able to find your lateral area. Now, L, again, is smart to use for lateral area because it speaks to all the faces that are non-bases. So all those faces, those rectangular faces on this pentagonal prism, have an area of capital P times H. And then the surface area, capital S, smartly enough, capital S represents surface area, is capital PH, so it's the lateral area plus 2 times capital B. And that makes sense too if you say, again, capital B as the area of a base. This base has an area of B. This base has an area of B, so capital P times H plus 2 times B is the total surface area of this prism. Any prism for that matter. All of the faces, including the bases, are capital S, the surface area. Okay, cylinders. Similar to prisms, we're going to use a concept in relation to perimeter. What I'll maybe do later for you is put parentheses around 2 pi r and write capital P up above. Because as it turns out, the base, because it's a circle, has a circumference, or P if you prefer. I'll use capital C maybe for circumference here. Anyways, it's similar to perimeter in that it's simply the distance around the circle. So 2 pi r, if you remember, is the circumference of the circle. And then again, just times h. Just like lateral area for prisms, cylinders have that same basic idea. Surface area, so lateral area is this. Surface area is that same quantity up above, so 2 pi r h, plus, though, 2 times b, capital B being the area of the base, pi r squared. Example, find the surface area of the cylinder. Okay, so capital S is 2 pi rh plus 2 pi r squared, just like we see up above. We do know r in the picture is 3.5. We know h is 6. We could easily plug it into the first part, so 2 pi times 3.5 times 6 plus, and then the second piece there, 2 times pi r squared, again 3.5 squared. So that analysis will lead to, in the following way, 66.5 pi, or approximately 208.92 centimeters squared. So that is the surface area of the cylinder, not just the surrounding lateral area, it's also the top and bottom circles combined. Let's move on. As you can see, I've already performed all the work for this, so I'll walk you through. Find the lateral area and the surface area of each solid. Round your answers to the nearest tenth if necessary. Now, the first thing I did is I identified the fact that the bases on number 1 are right triangles. So, of course, this is a triangular prism, we would say. Not only that, the perimeter can't easily be calculated unless you notice the right triangle can be related, of course, to the Pythagorean theorem. Because I know that this side squared plus that side squared is equal to the hypotenuse squared. So leg squared plus leg squared equals hypotenuse squared, or a squared plus b squared equals c squared. So 6 squared plus 8 squared equals c squared, and then of course that's going to end up being 10. It's a 6, 8, 10 right triangle, or a multiple of a 3, 4, 5. So c is equal to 10. From there, off to the left, you see p, the perimeter of the base, is 6 plus 8 plus 10, add up those 3 sides, and you end up with 24. The lateral area, therefore, is capital P, there it is, times the height, which is 9 in the picture. Therefore, 24 times 9, 216 meters squared for capital L, the lateral area. Capital S, take your answer to the first part, so 216, and simply add it to 2 times the area of the base. And remember, the base area, because it's a triangle, capital B separately is equal to what? 1/2 base times height. This is the triangular area. 1/2 6 times 8, which then is simply 24. I plugged it into the formula appropriately, and I ended up with 264 meters squared. Number 2. This again is a prism. More specifically, I would actually call this a rectangular prism because the bases are rectangles. And then I go ahead and do my math as far as the base goes, the perimeter and area separately. The perimeter of the base is 2 times 6.8 plus 2 times 3.6, which is 20.8. The area of the base is 6.8 times 3.6, which is 24.48. Again, why I did that speaks to back when we talked about the generic formulas for prisms, capital P times H and capital PH plus 2B. All right, so lateral area, 20.8, which is what I just got for P, times 2.1, which is the height, as you can see right here, of the prism. Do the math, and you'll end up with 43.7 centimeters squared for capital L, the lateral area. Capital S, take the answer from the last step, 43.7, and add it to 2 times what we got for the area of the base. If you do that, the math ends up giving you 92.6 centimeters squared. That is the surface area. 3 and 4 are both cylinders, so let's take a look at those. The area of the base here is simply pi times r squared, which is 25 pi. So I leave that kind of separate before I dig into the application of lateral area, which again is 2 pi times r times h. Now technically 2 pi r is just the circumference, but it's all kind of combined here as you can see. So 2 pi times 5 times 3.8, again 3.8 being the height, 5 being the radius. The lateral area then ends up being 119.4 centimeters squared. The surface area is the lateral area plus, again, the answer that I got over here, 25 pi, the area of the base, but because there's two bases, multiply times 2. So 119.4 plus really 50 pi, if you think about it, and that ends up being 276.5 centimeters squared for the surface area. Number 4, we'll approach it similarly. The area of the base is pi r squared, which I ended up, because the radius is 1.2, 1.2 squared times pi is 4.5. Lateral area, 2 pi r times h. In this case, r is 1.2, h is 8.3, and that ends up being 62.6 meters squared. Last but not least, surface area. If you add 62.6, which we got in the last step, plus 2 times 4.5, which again was the area of the base, 2 of them equates to obviously a full surface area plus the lateral area. In the end, 71.6 meters squared is your final answer.